corner points and points of vertical tangency. Maybe these topics were discussed, right?
Yes, sir, they were discussed.
Yeah. I think chapter 2.2 is done. Please confirm me whether I have completed the chapter or not.
Yes, sir, it has been completed, but we did not do any exercises.
Okay. We completed the chapter, but we didn't
Do
solve
any?
any
Yes,
exercise
sir.
problems,
Yes,
right?
sir. We did not solve.
Okay, so actually in this chapter, we don't need to go through the exercise problems because you know how to differentiate and you know the rule of differentiation. Uh, I'm leaving it for your homework. You can solve few problems from 9 to 14 and 15 to 20. Okay? And I hope you can
Okay,
solve
sir.
any problem from this chapter. It's not a difficult one for all of you in this level. Now we are moving to section 2.3, where especially we'll be discussing some techniques or some set rules for differentiation. And this is very well-known chapter, very well-known formulas for all of you. Because in this chapter, actually, the rules or the formulas that we studied in our intermediate level is listed, and I hope most of the problems are very much familiar to all of you. The first rule is differentiation of a constant function is 0. So ddx of any constant is 0. There are some examples you can check. Then comes the power rule, differentiation of a power function. That means if n is a positive integer, then ddx of x to the power n is equal to nx to the power n minus 1. Okay? So this is known as power rule. So based on the power rule, you can solve few of the problems given in example 2. All are simple problems. I hope you can solve it by yourself. The third rule is constant multiple rule. If a constant is multiplied with a function, and then if we take the differentiation, then it becomes constant times the differentiation of the function. That means constant should be taken outside the differentiation. This is known as constant multiple rule. Next, sum and difference rules. If we are given two functions f and g, then taking their sum and afterwards taking the differentiation is exactly same as taking their differentiations separately and adding them together. This is known as sum rule, and similarly we can take the difference of the two function and their differentiation. Okay, so very simple. I can skip the examples. I hope you will be able to solve the remaining problems. Then higher derivatives. Next topic is higher derivative. Higher derivative means taking derivatives successively, or sometimes you can say taking higher order derivative. First derivative and then differentiating the first derivative function gives you second derivative. Differentiating the second derivative function gives you third derivative. Likewise, we can move to or we can reach to any derivative. And as a whole, these derivatives are known as higher order derivative. So the order of differentiation is denoted by dny by dxn. So this is the nth derivative of the function y. You can write it down using this notation, and also there are several other notations, but the meaning is same. Okay, whichever notation you use, the meaning should be same all through. So as a whole, this is known as higher order derivative, or order notation is placed here. Okay. Now example 9 is an example of successive differentiation, or you can say the differentiation of the function successively. First differentiation, second differentiation, third, fourth, fifth, and up to nth differentiation, or n order differentiation. Okay. So we are done with this chapter. From the exercise set, you can solve a few problems from 1 to 8. Just take one problem from this segment. From 9 to 16, very simple. You can solve any problem from 9 to 16. From 17 to 18, 19 to 20. Okay, so up to 24, try to solve few problems. I hope you can solve any problem from this chapter. It's not difficult at all for all of you. Yeah, so we are done with this chapter. Now moving to the next chapter. Next chapter is 2.4, which uh, gives us two specific rules of differentiation. One is product rule, another one is quotient rule. So product rule means taking the differentiation of product of two functions. Product rule gives us the luxury of taking the differentiation of the product of two functions. You already know the rule. The rule is ddx of fx gx. That means the product is fg. The product of two functions f and g, and taking their differentiation. The rule is first take one function as constant and take the differentiation of the other, plus vice versa. Do you understand this rule?
Yes, sir.
Oh, yes, sir.
Yeah, I think you solved a couple of problems beforehand using this rule, right? This is an example. Example 1. You can solve the problem, you can solve the differentiation, or you can take the differentiation using product rule. The first function is f, which is 4x squared minus 1. You can consider this function as fx, and the next function 7x cubed plus x, this is the next function gx. So once you take the product rule, using the product rule, use the product rule formula and just separately differentiate and product with the other function, and finally simplify. Okay, so this is all about product rule. You can solve the same problem using multiplication. First, multiply the products of the two and you will get a polynomial function, and then apply the differentiation rule to get the result. But remember one thing, if you are asked to use product rule, you must have to use product rule. You cannot apply any other alternative rule. You must have to use product rule. If your question is like solve or take the differentiation of the given function using product rule, then you must have to apply product rule. Then derivative of a quotient, that means derivative of a quotient function. Using the quotient function rule of differentiation, we can take the derivative of any quotient function. Quotient function means P by Q form function. That means in such a function, we have a numerator and a denominator, and the ratio of this function is known as quotient function. And the rule is ddx of fx by gx equal to gx into f prime x minus fx into g prime x divided by whole square of gx function. Have you studied this rule before?
Yes, sir.
Yeah. So I think you can apply this rule to get the differentiation of a quotient function. Very simple and very easy as well. So recommended problem for this chapter is from 1 to 24.
Sir, sir,
Yeah,
can you mark the important maths to practice?
yeah, I said already. 1 to 24. These are your recommended problems from this chapter, from this exercise.
Okay, sir.
1 to 24, okay? And these are all easy problems. You already solved these problems many times before. So I don't think that you need to practice problem from this chapter. The next chapter is derivatives of trigonometric function. This is another fundamental chapter. So in this chapter, you just take the differentiation of trigonometric function by direct formula. Okay? So can you remember these formulas? You studied many times before.
Yes, sir.
What is the differentiation of tan x?
Sec square x.
Yeah. So there are 6 special formulas for this chapter for trigonometric differentiation. And based on these formulas, you can solve any problem from this chapter. So these are your homeworks. You just go through the problems and apply your known formula to solve the problem. Okay. The next chapter is chain rule. This is also, yeah, this formula is also known to you. I hope you applied the chain rule in your intermediate level. So chain rule means when we take composite function or the composition of several functions, then it helps us evaluating their derivatives using chain rule. For example, if we consider y is a function of f and its input is g. That means y is a function of gx. So y equal to f of gx. And u is another function. U is a function of x. So u equal to gx. Then y eventually becomes a function of u. Just replace gx by u gives us y is a function of u. And now we are allowed to take the derivative of y with respect to x. Means y is a function of u. So first we need to take the derivative of y with respect to u and then u with respect to x and multiply them together. This is known as chain rule. I hope you can recall this formula.
Yes, sir.
So example 1, where you can apply the chain rule to get the derivative of the function y equal to cos x cube. So this is not cos x, rather this is cos of x cube. Okay, so you can apply substitution, that means u equal to x cube. Then y becomes y equal to cos u. Now y has become a function of u and u is a function of x. So using chain rule, first we take the derivative of y with respect to u and then u with respect to x. And finally we get minus 3x squared sine x cube. Or you can directly make the differentiation using direct rule. Do we? Can you make the differentiation using chain rule?
Yes, sir.
And this is the alternative version of the chain rule, okay, where you can directly get the differentiation or you can directly get the derivative without applying the detailed version of the chain rule, okay. That means whenever you are asked to get the derivative of cos x cube, first consider it as cos x. So what is the differentiation of cos x?
Minus sin x.
Minus sin x. And here instead of x we have x cube, right? So what should be the differentiation of x cube?
3x square.
3x squared. So therefore directly you can write minus 3x squared sin x cube. Okay, so this is known as the shortcut or alternative formula of chain rule. So I hope you will be able to solve all the problems from this chapter. Still, if you have any doubt, you can pick some problems from 7 to 26 from this exercise set to just for practice purpose, okay? I hope you can solve, but still if you have any doubt for practicing, you can choose few problems from 7 to 26. I think that would be good enough. Okay, so this chapter is done. Now we are moving to our next chapter, chapter 3. The important topics that have been discussed in this chapter is all about application of differentiation in real life. Okay, the first thing or the first topic that has been discussed in this chapter is implicit differentiation. Implicit differentiation means the differentiation of a function which is expressed in terms of a common or in terms of a common input. Okay, that means a function which is a function of a given independent variable. For example, y equal to f of x, this form is known as explicit form because the function is explicitly described. That means y is a function of x, or you can say y equal to f of x means y is a function of x only. And this expression is known as explicit form of function, and the differentiation that we need to follow is explicit differentiation. Now, if the function is expressed in implicit form, then the differentiation we need to apply is known as implicit differentiation. Now, someone can ask me how an explicit function can be described. Explicit function means x and y are in a mixed form. Okay? So when we apply implicit differentiation, the function is given in a mixed form. That means x and y are in a mixed form. For example, equation 1 is an example of implicit function. Do you understand? Do you understand the difference
Yes,
between
sir.
Okay. In some cases, an implicit function can be converted into an explicit function, but it is not true for all implicit functions. Some implicit functions can be converted into explicit form, but it is not guaranteed that all implicit function can be converted into explicit form. Okay? So we'll show the application of implicit differentiation using a simple example for example 2. Okay. So example 2 gives us a very simple idea how implicit differentiation is done or how an implicit differentiation can be taken. Okay. So the given function is pi y squared plus sine y equal to x squared. This is an example of implicit function. So whenever we take the derivative of an implicit function, we must take implicit differentiation. And the set rule is just take differentiation on both sides. So what is the differentiation of 5y square? According to the constant multiple rule, 5 should be taken outside. Then differentiation of y squared. What is the differentiation of y squared? Actually, here y square is differentiated with respect to x. So y is a function of y. Y is not a function of x here. So first we have to take the differentiation of y square with respect to y, then y with respect to x using the chain rule. Do you understand? I hope you did implicit differentiation in your intermediate level, right? In your HSC level. Did you?
Yes, sir.
So do you have any confusion regarding implicit differentiation? Implicit differentiation কি কার কোনো confusion আছে? Do you have any confusion? Please confirm if you have any sort of confusion.
No, sir.
No, sir.
Okay.
No, sir. Okay.
Now move to the example 4. Find the slopes of the tangent lines to the curve at the points 2, minus 1 and 2, 1. That means at the beginning you are given an equation which is expressed in implicit form, and then you just need to find out the slopes of the tangent lines at two particular points. One is 2, minus 1, another one is 2, 1. So you already know how to get the equation of a tangent line. Do you have any idea how to get the equation of a tangent line? Or how to get the equation of any straight line? Do you have any clear idea? To get the equation of a straight line, we need to know the slope of the line, and additionally, we need to know the point through which the line will be passing. Knowing a slope and a point is good enough to get the equation of that straight line. And this form is known as point slope form. Am I right?
Yes, sir.
That means the thing is very simple. First, get the implicit differentiation and then find out the value of the slopes at the two given points. Once you know the slopes and you know the passing points, then you can get the equation of the tangent lines, right? Is that clear or you have any queries or confusion? Just take 5 minutes to understand example 4 and then ask me if you have any problem.
Sir, I have a question. Why did we take the square root to determine y and then differentiate? We could just differentiate the equation on both sides.
Yeah, but the given equation is an implicit equation. So you must take implicit differentiation to get the derivative. Implicit function has a standard form f of x comma y equal to 0. This is the standard form of implicit function, whereas y equal to f of x is an example of explicit differentiation or explicit function.
Okay, sir.
First, you have to understand whether the function is given in the form y equal to f of x. That means all the x values are on the is located on the right hand side, and in the left hand side only y is given, y equal to f of x. This form is known as explicit form. So you have to apply explicit differentiation for that. But if x and y are in a mixed form, that means f of xy equal to 0, then you must take implicit differentiation for that. Okay, just go through problem number 5. Example 5, this is very important type of problem from this chapter. It has 3 parts altogether. So just try out first, then I will discuss. Take 5 minutes to read out the question and the steps to solve the entire problem. There are 3 parts of this problem. You have to go through the problem and you have to solve the problem step by step. Okay? Have you gone through the problem?
Yes, sir.
The first thing is take the implicit differentiation and then get the values of the slope at that point. And once you have the slope as well as the passing point, you can get the equation of the straight line. Okay? And in the third part, at what points or point in the first quadrant is the tangent line to the folium of Descartes horizontal? Okay, one thing I forgot to announce. This is a very special equation. This is a well-known equation which is known as folium of Descartes, x cube plus y cube equal to 3xy. And this is also a famous example of implicit differentiation, or you can say implicit function. Okay. And for the third part, you just need to find out the point where the slope is horizontal. That means the slope value is 0. Horizontal slope means 0 slope. So the tangent line is horizontal at the points where we get the derivative equal to 0. So just taking the derivative equal to 0 means taking y squared minus x squared by y minus x squared by y squared minus x equal to 0, and solving the equation, we get two x values. One is 0, another one is 2 to the power 1 by 3. So substituting the x values into the function, we get the corresponding y values, and combining them together, we get the points where the slope is horizontal. Since in the question it is given, we have to find out the point which is located in the first quadrant. So the only point located in the first quadrant where the slope is horizontal is this point, 2 to the power 1 by 3, comma 2 to the power 2 by 3. This is the only point in the first quadrant where the slope becomes 0. That means we get a horizontal slope at this point. Okay, so this chapter is done. Very simple chapter, and recommended problems from this chapter is 25 to 28. These 4 problems. But if you have any confusion regarding implicit differentiation, then you must solve problems from 3 to 18. Solving problems from 3 to 18 will help you boosting your confidence regarding the implicit differentiation. Okay? Chapter 3.2 is our next chapter, where you just need to follow 3 special formulas and nothing else from this chapter. Chapter 3.2 is all about studying 3 special formulas. The first formula is this: limit v approaches to 0, 1 plus v to the power 1 by v equal to e. This is the first formula of this chapter. The second formula is ddx of ln x equal to 1 by x. And the third formula is ddx of log b base x equal to 1 by x into ln b. So based on these 3 rules or 3 differentiation formulas, you can solve the remaining problems from this chapter. Okay, so this is your homework. Just revise the formulas and get the differentiation. Okay. All right. So 3.3 is not included in your syllabus. Now we are moving to 3.4. Chapter 3.4. This is an important chapter for all of you. And this chapter is all about related rates. This chapter dedicatedly deals with related rates. That means the rate of change of any particular quantity with respect to time. Okay, so whenever we say rates, it actually indicates a change with respect to time. So in this chapter of related rates, we take the change of any quantity, that means the quantity or the function having several independent variable and their change with respect to time. For example, V equal to 1 by 3 pi r square h. This is the volume formula of any right circular cone. You know the right circular cone?
Yes, sir.
So here, what are the independent variables of the volume function?
Sir, I think H is independent.
Only h? Don't you think r is also an independent variable?
Yes, sir.
By changing the radius, you can vary the volume, right? As well as the height. Just look at the figure. You can change the volume of a liquid stored inside this circular cone, right circular cone, by changing its height as well as its radius. So volume depends on R and H. That means radius and height both are independent variables for the volume. Okay. So now related rates means if you want to calculate or if you want to trace out the rate of change of its volume, that means dV by dt, then it is mandatory or it is necessary to consider the rate of change of its volume and its to get the rate of change of its volume require calculating the rate of change of its height as well as the rate of change of its radius. That's why if you apply dV by dt on the left side, then you must apply the product rule on the right hand side with respect to time, t. Do you understand? Do you understand the expression given on the right
Yes,
side?
sir.
Okay. So this is how a related rate problems can be solved using differentiation. Do you understand?
Yes, sir.
Okay. So now move to example 1, the most easiest example of this chapter. Suppose x and y are differentiable functions of t. That means x and y both are differentiable function of time. T means time. And are related by the equation y equal to x cube. That means x and y are related by the relationship y equal to x cube. Now you are required to find out dy by dt at a particular time t equal to 1 and a given condition x equal to 2, and dx by dt equal to 4 at time t equal to 1. That means you have three pieces of information. One is if your time is 1, t equal to 1, then x should be 2 and dx by dt should be 4 at the same time t equal to 1. So based on the given information, you need to calculate dy by dt. So let's start with the given equation y equal to x cube. Now apply d by dt on both sides. That means apply the differentiation of the function with respect to time on the both sides, because this is a related rate problem. So we have to apply the differentiation with respect to time t. All right. Then on the right hand side, dy by dt equal to, so on the right hand side, ddt of x cube. So you have to apply chain rule on the right hand side. Since x cube is a function of x, so first you have to take the differentiation with respect to x and then x with respect to t. So eventually it becomes 3x square into dx by dt. Okay, is that clear? And now you have to apply the initial conditions or the given conditions. So what were the given conditions?
Sir, ask the question again.
Okay. The question is, you have to apply the initial conditions or the given conditions to get the value of the derivative dy by dt, or you can say the related rate of y with respect to time t. Okay. The initial conditions are x when x equal to 2, dx by dt equal to 4 at the time t equal to 1. So after taking the differentiation using chain rule, we have dy by dt equal to 3x square into dx by dt. So when x equal to 2, dx by dt equal to 4. So just replace the values and eventually you will get dy by dt equal to 48. Do you understand? Is that clear?
Yes, sir.
Okay. So moving to the next problem now. Just read the statement of the problem. and I'm giving you 2 minutes to read the statement and then I will discuss. Have you gone through the statement? Have you understood the statement?
Yes, sir.
So we are dealing with the problem of ruptured tankers. So oil spilled from a ruptured tanker spreads in a circular pattern whose radius increases at a constant rate of 2 feet per second. How first is the area of the spill increasing when the radius of the spill is 60 feet? That means to deal with such a problem, you need to understand the natural shape of the problem or the physical appearance of the problem. So if oil spill from a ruptured tanker, then the spreading pattern is a circular shape which has different radius at different times. That means if we consider a ruptured tanker, then oil spreads like a bubble, okay? And it has a round circular shape having a special or having a particular radius. And the radius increases at a constant rate 2 feet per second. That means as time goes on, or you can say as time passes, the radius gets bigger and bigger, right? So to deal with such a problem, we must follow the set formula or the set rule of the area of a circle. You know the formula of area of a circle? Do you know?
Yes, sir.
What is the area formula?
Pi r.
squared.
That means area is related to radius. Since pi is constant, so area is completely dependent on radius. So we have to take the related rate with respect to time to both the area and the radius r. Okay? The easiest way is to first define the related or the relevant quantities by some letters. For example, here we need to consider time. So T, small t stands for time elapsed. R stands for radius. A stands for area. Okay. So combining all these three letters, we can solve the problem. As we can see, the radius is increasing. So dr by dt is 2 feet per second. This is given. And we need to calculate the rate of change of area. So dA by dt at a given instant, which is 60 feet. So when the radius takes a special value, which is 60 feet, what should be the rate of change of area at that particular instant? Okay. So this is your given condition, and we need to calculate this value at a particular instant, which is when radius is 60. Okay. First, take the differentiation, and once we have the differentiation, replace r equal to 60 and dr by dt equal to 2 to get the desired rate of change of area. Clear? Very simple. Is that clear, or you have any confusion?
Yes, sir.
Okay, so to solve such a problem, to solve related rates problem, there are 5 common steps. So if you follow these 5 steps, you can solve any problems based on related rates. Let me summarize the steps. Step number 1, first assign some letters to some quantities which are relevant to this problem. Step 2, identify the rates of change which are known and which are unknown. Step 3, set an equation. That means you have to understand the physical appearance of the problem, and based on the physical appearance, you have to set a formula for that. Just for example, in the last problem, we understood that the formula is area of a circle. So in every single problem, you must set an equation, you must find an equation, and you must set a formula for that. Step 4, you have to take the differentiation with respect to time on the both sides of the function. And after completing step 4, you can substitute the values of the given formula and the given condition to get the unknown rate of change. Okay. I hope we can conclude today's class here, because the next problem is very important problem for us. So I want to discuss this problem in my next class. Okay.
Yes, sir.
Which is supposed to be held on next week. So if we require any additional class, I will ask you to join some online session, or if you have any available slots on next Tuesday, because I have an extra class with software engineering on next Tuesday from 3:45. So if you have any free slots before that, you can ask me. I can set a extra class for you on that day. Okay.
Sir, are you taking our quiz next week?
Yeah, of course.
Sir, can I ask what will be the syllabus for that?
Basically chapter 1 and 2.
Okay, sir.
The topics that we discussed in chapter 1 and chapter 2 should be the syllabus for your next quiz. But if you
Sir,
if
will
you
the topic of inverse function be included?
inverse function in which section? Maybe
Sir,
this
when
section?
chapter functions, sir, chapter 0, I think.
Chapter 0 is all about building your basics, or how should I say, elementary chapters for your differential calculus. So chapter 0 is not directly included, but you have to have the concepts or basics of chapter 0 to solve any chapter, any subsequent chapter. Okay? So basically chapter
Okay, sir.
1 is 0 is not included, but it is included in a passive way. How can I say? তোমার ওই চ্যাপ্টারের কনসেপ্ট বা বেসিক জানতেই হবে, আদারওয়াইজ ইউ ক্যানট go for other chapters. Okay?
Okay, sir.
So thank you so much for joining today's class. Attendance is given to all of you. So thank you so much. And let me know if you have any free slots on next Tuesday.
Sir, can I ask up to which chapters are we covering for mid?
Uh, Tentatively up to chapter 4.
Sir, if we take another extra class, will we be able to cover that syllabus?
I hope so. Hopefully so.
Okay, sir.
So please try to squeeze out some time on next Tuesday so that we can have an offline class on that day, so that we can have at least 2 more classes before the meet. Okay?
Yes, sir.
And I hope that would be helpful for all of you. And if it is required, then we can have we can have an online class to discuss the whole syllabus set for the mid exam, the review class kind of. Okay? And that should be after the scheduled class, obviously. After completing your scheduled class, we'll set an online class for reviewing the entire syllabus for the mid exam.
Okay, sir, that will be better.
Yeah, I always do such online class every year so that all students get aware of what the syllabus is set and how should they prepare for the mid exam or final exam. Anyway, thank you so much. Let me conclude today's session. Thanking you all for joining today's class. Hope to see you on next Thursday. Oh, sorry, if you have any time on next Tuesday, it's also okay. Thank you.
Assalamualaikum, sir.
Walaikum assalam.
Assalamualaikum, sir.